On this 2011 to 2022 Ford F250 Superduty with the 6.2-liter V8, P0301 means the PCM has detected a misfire on cylinder 1. The truck may run rough, shake at idle, hesitate under load, or set the MIL. If the MIL is flashing, treat that as a catalyst risk misfire and don't keep loading the engine. Broadly, this code can come from possible ignition trouble, fuel delivery to that cylinder, compression or base engine concerns, vacuum or EGR effects, or a crank and cam signal issue that affects misfire detection. Start with the basic system checks, then stay on a structured path so you don't turn a cylinder 1 code into a part swap. For P0301, the misfire path starts by checking what other codes are present. If a crank or cam correlation style fault is present, the path moves toward cam and crank signal checks. If the codes are misfire related, continue into the misfire routine. If no related code is present, move to symptom-based testing instead. Before clearing anything, record the captured misfire data from the PCM, because clearing PCM DTCs erases that captured data. Compare the recorded PIDs to typical reference values. If something is already out of range, treat that as an intermittent or circuit direction before going deeper into cylinder testing. Next, run a relative compression test using the scan tool routine. If all cylinders pass, continue. If a cylinder does not pass, move into cylinder leakage testing on the suspect cylinder, and if needed, follow with a compression test on that cylinder. After that, check for other non-misfire continuous memory codes, then KOEO codes, then KOER codes. If other non-misfire codes are present, stop chasing P0301 for the moment and diagnose those first. A misfire code can be the result of another control problem, so don't ignore the other fault just because the truck is shaking. Now run a cylinder power balance test. If all cylinders contribute correctly during the test, the path moves ahead to injector flow. If the test shows a cylinder contribution problem, go into the ignition branch. If the scan tool routine is not available on the vehicle, follow the path that lets you continue the diagnostic sequence rather than stopping the job. When the path sends you into ignition testing, keep safety and component protection in mind. Do not disconnect a coil on plug while the engine is running, because coil or PCM damage may occur. Also, inspect around the catalyst and muffler area for heat damage if the ignition system has been failing, because a damaged ignition system may drive catalyst temperatures high. If the ignition branch confirms an ignition concern, repair what the test proves, clear PCM DTCs, and repeat the self-test. If ignition is not the problem, return to the main misfire path and continue with fuel testing. Next, run the relative injector flow test with the scan tool routine. If all injectors flow correctly, continue. If an injector does not flow correctly, check for loose connections and damaged or corroded pins. Repair as needed, then continue into the fuel system checks. If the fuel system path finds a concern, repair it, clear PCM DTCs, and repeat the self-test. Then inspect the vacuum system. Look for damaged or deteriorated vacuum hoses, restrictions, and evap hose or line connections that are wrong or damaged. Some vacuum leaks can be heard. If a vacuum concern is found, repair it, clear PCM DTCs, and repeat the self-test. The path also includes an EGR check in this area. Treat it as a commanded versus actual check. Bring the engine to normal operating temperature. Monitor the EGR-related PID for this application. Record values at idle and with ignition on engine off, and compare them to typical reference values. If the EGR values are out of range, diagnose the EGR system. The next step disables the EGR system, then uses the captured operating conditions and customer information to reproduce the misfire. The PCM may store EGR-related codes during this process. If the branch you are following does not clearly bring you into this EGR path, pause, recheck the earlier diagnostic path. If the path continues past vacuum and EGR-related checks, inspect for base engine concerns. That means evaluating engine integrity and related mechanical contributors such as fan and accessory drive effects, compression, leakage, valve train condition, PCV issues, component concerns, and intake runner control where applicable. Mechanical noise from accessory drive components, cooling fans, or rough road high RPM light load operation may create a misfire-like loss of cylinder acceleration. If no base engine concern is found for this cylinder-specific code, command the suspect injector off with the PCM injector disable PID and watch engine RPM response. If RPM changes, keep moving through the path. If RPM does not change, inspect the suspect injector connector and pins for damage, corrosion, or incorrect connection. If no connector concern is found, the supported repair is to install a new fuel injector, then clear PCM DTCs and repeat the self-test. The next part of the path looks at the signals that the PCM uses to identify misfire. Start the engine and monitor the sync status PID for a cam sensor concern. Then check for excessive generator electrical noise. Listen with the engine running, shut the ignition off, disconnect the generator regulator B+ connector, restart, and see whether the noise remains constant. If the noise changes, move into charging system diagnosis. If it stays constant, inspect the CKP harness for intermittent damage or physical problems. Then inspect the crankshaft pulse wheel, crank pulley, and CKP sensor area for damaged teeth, wobble, looseness, or sensor damage. If the CKP sensor, pulse wheel, or crank pulley is not okay, repair as needed, confirm correct CKP installation, reset cam, and carry out misfire monitor neutral profile correction with the scan tool. After the crank signal checks, look for a biased upstream oxygen sensor concern by running the engine, recording EQ ratio and fuel trim PIDs for both banks, and comparing them to typical reference values. If the data points to a biased oxygen sensor issue, check the oxygen sensors, exhaust system, and mounting flanges for leaks or damage. Repair as needed, clear PCM DTCs, and repeat the self-test. Then, check recent repair history for rotational components such as crankshaft, crank pulley, camshaft, flex plate, flywheel, pistons, connecting rods, or front-end accessory drive components. If that history is present, carry out misfire monitor neutral profile correction with the scan tool. Then reproduce the original conditions and verify the mode 6 misfire count is below 10. If not, move into the intermittent diagnostic path. When you enter the ignition branch, start by checking the active DTC direction without reading the whole family of misfire codes out loud. For this P0301 case, continue through the misfire path unless a transport mode related code changes the next move. Run the cylinder power balance test again in this ignition branch. If all cylinders contribute correctly, do the ignition visual inspection. If they do not, move into the suspect coil power check. On the visual inspection, make sure the coils are connected correctly and securely. Inspect harnesses and connectors for damaged, burned, overheated, loose, or broken conditions. Make sure the battery is in good condition with accessories off, and on the 6.2-liter engine, check the exhaust spark plug wire and boots. If that visual check finds the fault, repair what is found, clear PCM DTCs, and repeat the self-test. For the cylinder 1 ignition branch, check power at the suspect coil. Key off, disconnect the suspect coil connector, key on, and measure VPWR at pin 1 of the coil connector. Voltage must be greater than 10.5 volts to continue. If it is not, repair the open circuit, clear PCM DTCs, and repeat the self-test. If the cylinder misfire code is present, check spark on the cylinder indicated by the code. Disable the fuel pump by removing the fuel pump fuse. On the 6.2-liter engine, test both the ignition coil boot and the exhaust spark plug wire with an adjustable ignition spark tester, THX458 or equivalent. Use the specified gap sequence, including 40 kV, and judge spark at 25 to 28 kV while cranking. If spark is present at 25 to 28 kV, move to spark plug inspection. If spark is not present, move to component inspection. Inspect the ignition components on the missing cylinder. On the 6.2L engine, check the coil boots for damaged insulation or burns, inspect the spark plugs, and inspect the exhaust spark plug wires and boots for damage or burns. Measure spark plug resistance from the center wire to the terminal. During this component inspection, install a new spark plug if the resistance is lower than 2,000 ohms or higher than 12,000 ohms at a room temperature of 25 degrees Celsius, 77 degrees Fahrenheit. For the exhaust spark plug wire on this engine, resistance outside 5,875 ohms to 7,875 ohms at 25 degrees Celsius, 77 degrees Fahrenheit fails that wire. There's also a secondary coil resistance check used on F650, F750, and Transit Connect 2.5L applications, measuring between the suspect coil connector VPWR component side and the ignition coil spring in the boot. That check asks whether resistance is between 5,000 and 6,000 ohms. For this F-Series Superduty 6.2L coil, measure secondary resistance between the suspect coil high-voltage tower center pin and the ignition coil spring in the boot. That coil check should be between 33,900 ohms and 41,500 ohms at a room temperature of 25 degrees Celsius, 77 degrees Fahrenheit. If it's not in range, install a new coil unplug, clear PCM DTCs, and repeat the self-test. If spark output is good, remove and inspect the spark plug for damage, wear, carbon tracking, deposits, and correct gap. If the plug is not okay, repair the plug condition, adjust the gap, or install a new spark plug as necessary, then clear PCM DTCs and repeat the self-test. If the plug looks okay, measure spark plug resistance from the center wire to the terminal. Spark plug resistance should be between 2,000 ohms and 12,000 ohms at a room temperature of 25 degrees Celsius, 77 degrees Fahrenheit. If it is outside that range, install a new spark plug, clear PCM DTCs, and repeat the self-test. There is also a component confirmation swap path for certain bank-specific misfire decisions, where the suspect coil, spark plug, and fuel injector are moved against components from the opposite bank to see whether the misfire moves. Use that only if the diagnostic branch you are following clearly sends you there. If it does not, pause, recheck the earlier path, and do not force that branch into a P0301 diagnosis. Keep verification separate from testing. After any proven repair, clear PCM DTCs. Repeat the self-test. Reproduce the captured operating conditions when needed, and confirm the misfire does not return. The takeaway is simple. Prove cylinder contribution. Separate mechanical, ignition, fuel, vacuum, EGR, and signal detection causes in order, and only install parts when the test result supports it. For more diagnostic training, visit stepdiagnostics.com.